Now let us see about the constraint called set clock group. Ensures static timing analysis ignores timing paths or crosstalk analysis between certain clocks. So we will see what is meant by crosstalk in upcoming videos. So it is useful for asynchronous clocks, no deterministic phase relationship. So as I already told you, asynchronous clocks will not share a fixed phase relationship and it may come from two different clock sources. Next, mutually exclusive clocks, that is logically or physically. Without this, STA might try to check timing between clocks that never interact, wasting analysis effort and possibly generating false violations. So we need to carefully write a constraint saying the clocks are asynchronous. So this is the syntax: set clock group, hyphen name, some group name we have to give, and hyphen group clock list, and we have to tell whether it is logically exclusive or physically exclusive, and if they are asynchronous we need to use this particular switch, and allow parts and hyphen comment. So hyphen name is something unique name for the clock group. In order to give a name to the clock group, you have to use a switch called as hyphen name. And coming to hyphen group, so list clocks in a group. Multiple hyphen groups can be specified. Logically exclusive clocks don't interact logically but may have crosstalk. Whereas physically exclusive clocks never coexist electrically, no crosstalk analysis. Hyphen asynchronous. Clocks have no phase relationship, treated with infinite timing window. Next, hyphen allow paths, used with hyphen asynchronous to keep timing parts active while still performing crosstalk checks. Next, hyphen comments is optional text describing the group. So only one hyphen logical exclusive or hyphen physically exclusive or hyphen asynchronous can be used for command. So if you are writing a command, you can use only one. Either you can use logical exclusive or physically exclusive, if not hyphen asynchronous. Now let us see an example for logical exclusive clocks. So this is the example which you need to consider for logical exclusive clocks. Clocks C1 and C2 drive separate flops that never interact but may have crosstalk. So here C1 and C2 are two different clocks which are driving two different flops. There is no relationship between C1 and C2, that is they never interact. But as two wires are present parallelly, there may be a chances of crosstalk. Now how to write the particular constraint. So here C1 and C2 are clocks. So first we have to write create clock command. So if you don't know how to write this create clock command, please check my previous videos. I have made a detailed video on it. Now let us see how to write for C1 and C2. So create clock hyphen period 10 nanoseconds hyphen name C1 hyphen waveform. The 0 is rising edge and 5 is falling edge, and this is at get ports C1. Next, this is for C2. Create clock hyphen period 20 hyphen name C2 hyphen waveform 0 and 12. So rising is at 0, falling is at 12, and this is at get ports C2. So we have written create clock command for C1 and C2. Now we have to tell this C1 and C2 are logically exclusive. So set clock group hyphen logical exclusive hyphen group C1 and C2 means this group C1 and C2 are logically exclusive. Now coming to physically exclusive clocks. So generated clocks that cannot coexist on the same net. So you have to consider this particular example. On a single net, you should not apply two different clocks. So these two clocks are generated clocks, where GC1 is something that is generated from C1 and GC2 is generated from C2. So let us see how to write the constraint for GC1 and GC2. So these are something which are generated clocks. So that's why you have to use this particular command, create generated clock. I made a video on create generated clocks also. First please go and check that particular video. So create generated clock hyphen name. Your name is GC1 hyphen source. From where it is coming from? This is coming from C1, which is connected to 2:1 multiplexer. So for a 2:1 multiplexer, you need to consider here this pin is A, this pin is B, and here output is Z. So that's why hyphen source. This is get pins. Mux1 is the instance name followed by A pin. So here this instance name for mux is mux1 and it is connected to pin A. So that's why I'm writing as get pins mux1/A. Next, where I am applying this is at get pins. This is mux1 Z pin. So get pins mux1 Z. Use switch called as hyphen combination. Now write for GC2 also. Create generated clock hyphen name GC2 hyphen source. Now this is at C2. So this can be written as get pins instance name, that is mux1, and this is connected to pin B. So that's why get pins mux1 B pin. Next, here this is at the output pin. So that's why get pins mux1 is the instance name and Z is the output pin name of 2:1 multiplexer. Hyphen combinational and hyphen add is the switch that you need to use when two generated clocks are present on a single net. Now you have to tell like these GC1 and GC2 are physically exclusive. So set clock group hyphen physically exclusive group GC1 and GC2. So these two are physically exclusive. Next, if there are any asynchronous clocks with no phase relationship, timing parts should not be considered. So if there is anything called as asynchronous, simply go with a switch called as hyphen asynchronous. Make sure while you are writing set clock group, you need to use either logically exclusive or physically exclusive. If not, instead of these, you have to use hyphen asynchronous. Let's see this one. Set clock group hyphen asynchronous and hyphen group get clocks CLK123 and hyphen groups get clocks clock 4, 5 and 6, meaning these are asynchronous. Implies clock 1, 2 and 3 are asynchronous to 4, 5 and 6. No relationship assumed among clocks within the same group. Hyphen allow parts can be added to keep timing parts while still performing crosstalk analysis. So remember, this is one example where I am using hyphen asynchronous as a switch, meaning CLK123 and CLK456 are asynchronous. So coming to the highlights, use generated clocks for local exclusivity to avoid impacting other parts of the design. Options are mutually exclusive. One command cannot have both logical exclusive and physically exclusive. As I told you, you have to use either logically exclusive or physically exclusive. If not, instead of these two, use hyphen asynchronous. Crosstalk behavior differs. So logically exclusive crosstalk is considered. Physically exclusive crosstalk is ignored. So this is the thing they will ask in interview. So remember this point. So logically exclusive means they won't share any physical relationship. As these clocks C1 and C2 are present parallelly, there may be a chances of crosstalk. So crosstalk is considered. Whereas physically exclusive means we are applying two different clocks on a single net. So here crosstalk is ignored. Next, coming to asynchronous, infinite timing window for aggressor and victim overlap. So I'll explain you clearly in the next video like what is meant by aggressor and what is meant by victim. Like what will happen if aggressor is rising edge and victim is falling edge, or else if aggressor is falling and victim is rising. So I'll explain you different cases like what will happen with setup and hold with respect to aggressor and victim. Next, multiple groups can be defined in one command. Relationships are between groups, not within the group. So from one group to another group, they can be asynchronous, but not within the same group. And you can take this particular example. Here 1, 2, 3 and 4, 5, 6 are asynchronous. But we are not sure like what relationship exists between 1, 2 and 3 as well as 4, 5 and 6 within the group. So this is all about logically exclusive, physically exclusive and asynchronous.